Okay, it's done. Okay, so let's go. Okay, so let's go. Basically, today is our second days of online training program. So mainly today I talk about that non-parametric trend analysis, rainfall data use, and identify where is the high precipitation, where is the low precipitation, where is the no change. So this type of pattern, how we can easily use the Mann-Kendall test and also identify using the Google Earth Engine platform. We discuss about this topic, and then we talk about the global satellite mapping of precipitation and hourly precipitation time series chart, how we can easily create the hourly precipitation time series chart. We also try to discuss about that, and we also talk about the CHIRPS data. Okay, CHIRPS mainly is the climate hazard group infrared precipitation with station data, as well as how we can easily create the 1 year time series chart, as well as also create the annual precipitation time series chart. Then precipitation measurement, how we can easily measurement the precipitation using the remote sensing technique in Google Earth Engine platform. We talk about that, and calculating the average rainfall for past 35 years. Okay, and download the data in CSV file or Excel file. Mainly how we can easily calculate the average rainfall for past 35 plus years and download the data in Excel file. As well as we also discuss about that topic for the how to make the monthly precipitation chart. So mainly how can easily make the precipitation chart for the January, February, March up to December. So this type of monthly precipitation chart, how we can easily create, and total monthly rainfall versus monthly ndvi. Okay, what is the relation about the rainfall and ndvi? So this type of relation we also try to show in here. So when I can get the monthly rainfall is the high, then we also find out the vegetation is also high for this month. Okay, so this type of result we try to discuss in this online training program. So first of all, here you can see the non-parametric rain analysis rainfall data. So mainly I use here the first of all Bangladesh country region, but in this time I use your own region and then check the result about that. So basically in this time, mainly non-parametric test, it provide you the Kendall's tau B rank correlation. Okay, so it provide the rank correlation such as positive value. You can see positive tau value indicate the increasing trend. Okay, and negative value indicate the decreasing trend. So after when I use here the Mann-Kendall test, then Mann-Kendall provide me some rank correlation. Okay, and when this positive tau value, it's indicating the increasing trend, such as here I can see the blue color. This blue color identify,
Dark.
yeah,
Okay.
yeah, this blue color identify the positive tau value. Okay, Mann-Kendall's tau value.
Oh,
So
okay.
positive tau value identify the
More
increasing
rainfall.
trend. Increasing trend. Okay, so in this time, this type of region, blue color region, you can see the blue color region, it identify the
Okay.
increasing trend of precipitation for Bangladesh, as well as
Okay.
the white color. We can get some also white color. So white color is also showing the not high positive value, but it also positive value. It also indicate about the precipitation. Okay, but the highest indicating the blue color, after that white color and red. This type of red color pixel will identify the negative value. Okay, negative pixel value. So when I open the code in Google Earth Engine platform, then you can easily check the value. We can get the suppose blue color, this type of blue color, we find out the highest, or we can get the positive tau value or highest positive tau value. It's identify the or indicating the increasing the trend of precipitation. And the this type of red color, this red color pixel value identify the negative. Negative means that it indicating the decreasing trend of precipitation or rainfall. And white color identify it also rainfall, but not mass rainfall, but it also indicating the positive value, not mass positive value, a small positive value about the white color. Okay, so basically it's a trend, and these data we can analyze here the total 20 years data set. Okay, so using the 20 years data set, we find out what is the trend for the precipitation or what is the trend of the rainfall for Bangladesh. Okay, so using the Mann-Kendall test. So basically, Mann-Kendall test provide you this type of information. It provide you the Kendall's tau rank correlation, and when I find out the
Yeah.
positive value of this, then it indicating that increasing the trend, and when I find out the negative value, it indicating the decreasing the trend. So using this method, we can
Yes,
easily do for, yeah,
Mr.
yeah,
Rahman,
please, yeah.
one small question. For how many years data they are this Mann-Kendall is working on, is testing? How
Okay.
many years
So
data, or how is?
basically, there is the no limitation, but in this time, here I use there the total 20 years data set. Okay. So using the past 20 years data set, I take, and using this data set, I find
Mhm.
out what is the Mann-Kendall, about the what is the Mann-Kendall
Okay.
trend analysis using the 20 years data precipitation data set, and we can easily get the data set. But
Okay.
you can easily use the 20 years, 10 years, or 15 years. Okay, basically it find out the
Okay.
what
Okay.
is the rank correlation. Okay, when you can find out the
Oh,
positive, it indicating the increasing the trend, and when I can find out the negative, it increasing the decreasing the
negative.
trend of the precipitation.
Yes. Yes.
Same approach we can also
Yeah.
apply for the ndvi. Suppose ndvi,
Oh,
you can apply the Mann-Kendall test, and I find out, suppose you have the past 10 years data of ndvi or 20 years of ndvi. So just we can use here the
acha, acha.
Mann-Kendall and then find out where the increasing the vegetation, where the decreasing the vegetation, and we can also some classify. Suppose we can classify the suppose increasing trend, high, low, medium, moderate, increasing. So this type of classification we can also classify our specific distribution for the different place using the Mann-Kendall. Okay,
Understand.
so Mann-Kendall is a
This
non-parametric trend
Mann-Kendall.
analysis. Yeah, yeah,
Yeah,
please.
Mr. Rahman, this Mann-Kendall we can apply for any kind of data like temperature
Yeah,
or
temperature. Yeah. Any kind of
rainfall.
data. Yeah, any kind of data. Any kind of data,
Okay.
and we can find out where is the positive or increasing the trend, increasing
Can
the
we can we
temperature
can we
or
use
decreasing the
this?
temperature. Yeah,
Yeah, yeah. Can we use this for land surface temperature?
yeah, same land surface temperature we can also use. Suppose you can create the Landsat LST map, and now suppose using the modis LST map. So now using this data set, you want to find out where the increasing the LST and where the decreasing the LST. So this type of analysis we can also do.
Oh,
There is no problem. The simple
okay.
equation or function we have to use on this data set, then it automatically created
Yeah,
this type of analysis. Okay, and it is a
understood.
non-parametric
Understood.
analysis. So
Yeah,
candles tau be
and
rank. Yeah, please.
yeah, go ahead. Go ahead.
Okay, okay, okay. So basically, trend analysis is the finding a place where the something of interest is increasing or decreasing, and how much increasing or how much decreasing. So this type of value we can get from the trend analysis. And mainly in this time here we use, there are a lot of way for the trend analysis. In this time we are use here the Mann-Kendall's tau value. Okay, Mann-Kendall tau value in Google Earth Engine platform, it just provide the rank correlation, and positive tau value indicate the increasing trend, and negative value indicating the decreasing the trend. Okay, so here's I already show you that in here. So this is the Mann-Kendall test. As well as we also talk about the another data set. It's called the global satellite mapping of precipitation. Okay, and basically it's provide the, suppose short time period. Suppose today you want to check where the place in Bangladesh and the precipitation will be occurred. You want to find out, or it mainly provide the 3 hours. Okay, 3 hours, every 3 hours, what is the condition of the precipitation. Okay, so very short time, when you want to need for the very short time analysis, only for the hourly data set, or you need only for the 3 hours data set or 1 day data set, or for the present day you want to check what is the condition of the precipitation, where the where the rainfall is happen or where the rainfall is not happen, you want to find out, then this data set is very popular. Okay, and this data set provide you the every 3 hours, provide all time every 3 hours we can get the data set and analyze about the precipitation where the happen or not, we can easily find out about that.
And this
Yeah,
GS map you can get it from Google Earth Engine directly.
Yeah, we can
Mr. Raman?
directly get this
Import.
image from here. Then we can simply write the code for our own region and then find out what where the happen for the precipitation or rainfall. We can easily find out this type of. And where is that there is basically this time here the I use the legend such as this blue color. It's identify about the precipitation. The black color identify there is the no precipitation for that region. Okay, we find
White.
out. Yeah, and white color identify about the precipitation very low. Okay, but more
Very low.
precipitation it will. And we can also check about the measurement about the each pixel how much precipitation will be happen. This type of analysis we can also do in Google Earth Engine platform. So I also
Oh,
show you the later how to do it.
oh,
And we can
oh.
also make the hourly precipitation time series chart every hour. What is the condition or how much rainfall millimeter per hour, how much rainfall we can check the from this time series chart. Okay, so how I can create this type of time series chart I also show you the later for our practical session. So this type of chart provide you what is the condition of the rainfall per hour. Okay, we can easily get
Okay.
about
Okay.
this result. Okay, and this is the another data set. It's called the CHIRPS data set. It's mainly climate hazard group infrared precipitation with station data. Okay, it's make the combination with the station data, and it also global data set we can easily get from the Global Valley. And this data set mainly provide you the panted means that 5 days interval. Suppose every 5 days
Okay.
interval we can easily get the yeah, interval is the 5 day. Okay, 5 days average
Mr.
pixel of
Raman.
precipitation. Yeah.
Yeah, yeah, yeah. Mr. Raman, this is not the file, Mr. Raman. There is a one more file
Okay, okay. I import that and then show
which
you that.
covers.
Okay, okay. I import that and show you that. Yeah. Okay. So previous class you
Yeah,
also
yeah. You
send
can
me this
remove.
file, so that's why I also use it for
Yeah,
making
yeah.
this map.
Sorry.
No
Yeah, yeah,
problem.
yeah.
Okay, no
The
problem. I
last
change it
last
and
time.
do it.
Yeah.
Okay. Okay. So
Yeah.
basically, it's a painted data, charts painted data. It provides the precipitation. In
Mm.
this time, this color identify the highest precipitation or high precipitation. Okay, for this region. Okay, and it also painted data. Every 5 days interval, we can get the result from here from the painted charts painted data set. And we can also easily make the precipitation of 1 year time series data for the 1 year. What is the condition for the 1 year? Such as year of 2015. What is the condition of precipitation? Okay, we can easily calculate this type of chart and find out where is that low and where is the low. We can easily find out the result. Annual precipitation chart. We can also create the annual precipitation chart. Suppose if different types of year of 2011, 2012, 2013, 14. Okay, we can easily find out about the annual precipitation time series chart in Google Earth Engine platform.
This
Okay, as well as yeah,
average, Mr. Raman.
yes, yeah, yeah. Any question? Yeah. Okay, any question?
Yeah, I mean, this is yearly average data.
Yeah, it's yearly average data for year of 2011 to 2020.
This is a station data or for entire country data. For example, this is for entire Bangladesh data.
It's entered for Bangladesh data. It's entered for Bangladesh data, and this data come from the CHIRPS data set. Okay, CHIRPS data set. Suppose this
Chops.
type of CHIRPS data set
Okay.
provide this type of data.
Okay, got it.
And you can see this is the annual precipitation map. It create the annual precipitation map year of 2011 to 2022. So basically, this type of color identify here the highest or high precipitation for this time. Okay, and it's showing the average for it create the between this time period. What is the condition for the average? And we can find out this is the highest precipitation or rainfall happen in this region. Okay, and it's showing the lowest or rainfall for this region. Okay, so this type of result we can get from here, as well as we can also measurement of the precipitation. Okay, suppose you can measurement for the 1 year or 2 year. What is the condition of the precipitation per hour? How much millimeter? How per hour? How much millimeter precipitation occurred? So in this time we can find out for this it's the highest. Okay, so per meter per hour 1.5 millimeter, okay, or more than 1.5 millimeter precipitation occurred in this region. Okay, so this type of measurement we can also do, and also calculate how much area occurred for the 1.5 millimeter per hour precipitation for any region. So this type of calculation we can also do in Google Earth Engine platform very easily. As well as we can also calculate the average rainfall for past 35 years and download the data in CSV file. Okay, suppose you can calculate for the global, we can easily do, there is no problem, or any specific region, it is also no problem. We can easily do for the global as well as also can do it for a specific region for calculating the average rainfall for past 35 years and download the data in CSV file format or Excel file format. We can easily download, and we can easily make the monthly precipitation map. Okay, for suppose year of 2000, all of those month, 2001, all of those month, 2002, all of those month. So all of those month with their specific year, we can easily make the monthly precipitation chart, as well as we can also make the annual precipitation chart. Okay, for the annually for any region, as well as we can also make the what is the condition about that ndvi and monthly and monthly precipitation data. Okay, so we can find out, we can see this, the red it's identify about the precipitation, and this green identify about the ndvi. Okay, so now we can easily make the, we can see the when the precipitation is the high, ndvi is also high. Okay, so we can easily make this type of data set, what is the correlation about the ndvi and precipitation. So this type of chart how we can easily create, I also show you this in this tank. Okay, so now so go our practical session. So we'll start from one by one. From first we discuss about that okay, so Mann-Kendall trend analysis, how we can easily make this type of distribution for the higher, we can find out the high trend and low trend. Hello, so just I simply open. So okay, so in this time I simply import your own shape file and then try to check the result. Okay, so what is the name about that? Any poly.
No, any Emirates police.
Okay, any Emirates. Okay, so just I upload that. And now upload that file. Okay, first of all, I discuss about the data set. It's a CHIRPS painted data set. We are use the CHIRPS painted data set. Suppose in this time we can get the data set from year of 2001 to 2018. Okay, between this time period we can get the data set. Or if you want, you can also get the more. There is no problem. Yeah. Suppose you can see the data set about that.
Make it till 2022.
Yeah, no problem. You can see we can get the data set from 1981. Okay, 1981 to 2023. Okay, between this time period we can get the data set. Okay, so you can use any time period from this data set. Just put the start date and end date, or start year or end year. Put that, and you can easily make this for any time period about the data set. And this data set is that description you can see. Mainly it is a climate hazard group infrared precipitation with station data. Is a 30 plus years data set we can easily get. And it has one band, only for the one band. Precipitation, it's only for the one band. Millimeter per painted, this is the unit about that. And resolution
what is the resolution?
Yeah, 5,566 meters for the precipitation
So
resolution.
5 kilometers, 5.5 kilometers. Okay.
Yeah, yeah. This is the resolution about that.
What happened, Mr. Rahman? You're having cold?
Yeah.
Same here also.
Okay. Or we also can get the image properties monthly, painted, and yearly. We can get from here the monthly, painted, or yearly data set. We can get from here. Okay. So now we are using the data set in here. Okay. So
Okay.
okay, it's imported your shapefile. Just I simply change my shapefile and try to show the result about that region. Just import and change it and give the variable name as the RY. Now click the run. And also we focus the center of the shapefile. So use at the map dot center
Self.
object that RY post 10 and click to the run. Load it.
Why it taking time, Mr. Rahman?
Load it.
I think the shapefile is loaded.
Yeah, shapefile is already imported and also use the shapefile.
Yeah, it's only showing only to this red area. It's not taking the complete shapefile, I think. Or
Just I show the layer of the shapefile. Okay, it's loaded. Yeah.
yeah, yeah. So this time series is from when, Mr. Rahman?
It's showing the time series year of 2001 to 2018. But we can simply change it. Suppose I put
80,
here the from 2000
2022.
to 2020.
Ah,
Okay? December,
yeah,
January to December
2020, yeah, 2022 make it.
2020. Okay, now click the run. We check the result.
2022. Ah.
And in this time we have also need to change check about that our mean and max value about that. Okay, basically this mean and max value will be perfect work for the Bangladesh. So in this time we also need to change it. For changing this unit, we have to use the simply, okay, after loaded I will show you that.
Oh, the entire code is already there, Rahman.
Yeah, so I already write about the code for the Mann-Kendall. All of this code I write in here. It's just I show the result, then I describe how I can write the code. Wait,
Yeah, yeah.
first show the result about that region. You can also get the sum. You can see this type of blue color. So basically, it's identified for this region is that trend is the high trend, a positive high positive value we can get
Oh,
in here. So it's identify about that it will
okay.
be increasing the trend of precipitation or rainfall day by day between
Mm.
this year of uh, 2000 to 2022. Okay, with this time period for this type of blue color region, it's identified for this region the increasing of precipitation.
Mm, mhm, mhm. And bring up Mr. Rahman on the top to the northeast
Okay, it's also
area.
loaded.
It's loading. Okay, okay. Yeah, yeah, that area. Okay, okay. Jera area. Mm.
It's the total 22 years data set analysis from 22 years data. So that's it some time for analyzing about that.
Uh, mhm.
In the meantime, also check about the suppose you can see here, click on the inspector tab, and basically in this time it distributed according to the tau value of Mann-Kendall's tau value. So in this time when I click on this type of blue pixel value, you can see it's showing the result about the positive. We can get the positive candle 0.03. But when I click on the any red color, it's identify about the negative. Okay, so negative means that it decreasing the trend of precipitation, and this type of blue color, it's identify about that increasing the trend of precipitation. White color is also showing
Okay,
about
okay.
that positive value, but very then
Mhm,
lower than blue color pixel value. We can get that, but it also
mhm.
showing about the precipitation. But red color, it's identify about the negative. Okay, so there is the negative
Negative
trend
correlation.
or decreasing the trend of precipitation for this region. As well as so also you can see click on here. You know the negative trend about that. It's a positive trend. White color is a positive trend. You can see positive but low 0.01 then 7. As well as we can also suppose I click on here and then customer in this time is stress 98%. Then we can get the better view about that when I stress that. So basically in this time for this region the lowest tau value is that negative point 0.0022. This is the lowest, and highest value is that. Simply copy and paste here. This is the highest tau value. Okay. So now click to the run. So now we can get about the better result. It is showing about the highest tau value and lowest tau value. Okay. So highest tau value, it's indicating the trend, increasing the trend of precipitation, and lowest or negative pixel will identify about that decrease in the trend of the precipitation. Okay, so now it will be loaded. In the meantime, I'll talk about the function. Which function we need to use in here? In this time, we have to use the function, this function called the reducer Mann-Kendall's correlation. Okay, so it's a function. Suppose I already create the data set. So this data set, when you, not only for the data set, any data set, it can be ndvi, it can be ndwi, any types of data set. When you apply this correlation about that Mann-Kendall correlation, this function, it create a reducer that computes the Kendall's tau rank correlation, and positive tau value indicate the increasing trend, and negative value indicate the decreasing the trend about that. You can put any types of data, any types of data set, suppose 20 years data set or 10 years data set, 5 years data set. You can easily input in this function, and then it will be calculate about that what is the condition about that Mann-Kendall, where you can find out the positive, where you find out the negative. Okay, so I guess we can get the better result after add here that maximum and minimum tau value in our code. Okay. So let's go about that. I think we simply discuss about the full code, how it will be work. So first of all, I simply imported the region of interest. This is our shapefile boundary for this region. I display the layer of this boundary, then simply focus, then simply add here my start year and end year. Okay, and start month January to December. Okay, so after that I take a variable date start, and here I put the format. Basically it is the year, month and day. Year, month and day. So e date from year, month and day. So here I put here the year. So year is my start year, which I already mentioned in here, year of 2000. And then month is the start month. I already defined here the January, and date is that 1st January. Okay. Then in date will be, I put here the e dot y, month and date. So year, in year I already defined the in year, and then December. Okay, so it's just showing the December 31. Okay, so this is my date range or time range about that, about this analysis. After that, I have to use here the data set. So basically it's a data set about that, this data set, climate hazard group infrared precipitation. This data set here I use. So just I simply click on here, I can get all of this information. Just I simply copy this collection snippet. Okay, and then paste here about this, in paste here, and then just filter date. Okay, so in this time, this data set I want to filter according to this time frame. Okay, so just use here the filter date function and put here the start date and end date. Okay, start date and end date put here, and this data set have only one band, this band called the precipitation band. Okay, it's a precipitation band. So now I just simply use here to select the precipitation. Okay, so now it's created about that my data set. Okay, so now this variable rainfall, this variable stored my data set. If you want to check about the data set, suppose you can simply suppose print, suppose use here the print, and then copy the variable name rainfall, and use here the size function. So now it determine how much data uh, we are use, or how much data set we can create in here. So now you can see here it's showing that here total 1656 images we are used in this time for making this trend analysis. Okay, and if you want to check about the all of those images acquisition time, just simply use here the simply use here the print rainfall, click to the run. In this time I can get all of those images acquisition time period also. So here you can see it provide the image collection. So click on here. Here I can get the total, all of those total 1656, and all of those acquisition time. You can see it also showing about the acquisition time. Just I close it and then increase. You can see the 2020 1st January, then 6th January, 11th January. So every 5 days interval, I get these images. Okay, interval time is 16 day. Sorry, 5 day. Okay, 5 days interval. That's why it's this data set called the painted data set. Okay, so in this time we are using the painted data set and then make this type of image collection. So now my image collection is ready. Okay, so now this image collection I have to input in the Mann-Kendall correlation. Okay, for that I simply call my rainfall because it stored my data set. It stored my data set. Okay, so just I simply use here the call the rainfall and then use here the reduce. So how I can reduce? I want to reduce earth engine reducer Kendall's correlation. Okay, and mainly when I put here the Kendall's correlation, this is my data set. This is my data set, and this data set I put here the Kendall's correlation. Okay, so I put here the Kendall's correlation. Okay, and now you can see when I simply print this variable, so now it create a single image. You can see it's create a single image in this variable, create the single image, and this single image has two things. One is that you can see one thing is that called the precipitation tau. Okay, tau value. It creates the tau value, and mainly we already know about that when the tau value will be positive, then it means about that increasing the trend, and when I find out the tau value is the negative, it means about that decreasing of the precipitation. Okay, so it create the tau value. You can see precipitation tau, and its range will be -1 to +1. Okay, and it also provide about the precipitation p value. Okay, you can see we can also get the p value about that. In this time we just work about the tau. So for that you can see here, just I simply call the rainfall trend. From this rainfall trend I simply select the precipitation tau. This is this band. Okay, this band I simply copy from here and then paste in here. Okay, so it is the precipitation tau, and then click with my study area. So now I display the result. So here I can get this type of result. Okay, so here the blue color, if you want to check the pixel value about the blue color, so click on here, so now we can get the Mann-Kendall test will be positive. Okay, because it's showing the blue color, because positive color, positive, this value identify about the trend of the precipitation. So it's the increasing the trend of the precipitation. And when I click on the any types of suppose red color, it's showing the result about the negative. So negative means that it's the
Negative.
decreasing the trend of the precipitation. Okay, so basically
Okay,
this is the process. You can see it's reason about that how precipitation is the increasing. Okay, this region.
yeah, yeah,
Okay, this region you can see
yes, yes.
the decreasing about the precipitation.
Decrease.
Okay, so in this time we can get this type of result from here and easily find out where the high trend of the precipitation, where is the low trend of the precipitation. Okay, so this type of analysis we can easily do, as well as okay, so this is the code for the. Okay, so this is the process of just we are using this function Mann-Kendall's correlation, and using this function Mann-Kendall's correlation, we are doing any types of trend analysis. What is the trend for the negative or positive, high or low? So this type of trend for any data set, not only for the rainfall, you can easily apply the same things for the ndvi. You can apply the same things for lst. You can apply the same things for ndwi. So any types of data set, we can easily apply this Kendall's correlation and then find out this type of trend. Here is the high trend, here is the low trend. Okay, so this is the process about the Mann-Kendall's. I hope you can easily understand about that. Yeah, so any question in here, you can ask me about that. Any question for this
Yeah,
Mann-Kendall? Yeah.
It is fine. Once this is done, we can export it into
Yeah, we can also
GeoTIFF
export it
and open
as
into.
a TIFF format, and then just use the same code. Suppose this is the same code we have to use. Suppose export image to drive. Just use the same code. Suppose in this time, I'll just make here the curly bracket start and curly bracket in. First of all, image in this time, just simply in this time, it's the full. You can see it's the full about the image. Okay, just full things. Simply copy the full things and paste in here. Okay, then description, you can put any description about that, such as I can put the description such as uh rain rainfall. You can use any name, rainfall. And folder, we can get the folder as a suppose GE. File name prefix not need, simply remove that. Region is our boundary shape file. It's that RY. Scale is that 5566. Then simply download it. Okay. So after downloading, we can easily make the map. Okay. Suppose I already write the some map. Just I show you the example. Suppose I
Yeah.
open it.
So
Suppose
this map is the correlation of the data from 2002 to 2022.
2022. Yeah. Total 20 years, 22
Yeah,
years.
22 years.
Yeah.
Okay, okay.
Suppose you can see here. Just yeah. Suppose you can see this is the one kind of example for the NDVI. Okay. So basically in this time here you can see is the NDVI linear regression trend analysis for NDVI in Delhi. So it is another about the linear regression. I also talk about that. In this time I show you the Mann-Kendall. But we are also showing the linear regression for the further analysis when I talk about NDVI. So from that we can easily can see identify about that trend analysis from year of 2013 to 2021. Here we can find out the high vegetation gain. It's identify the high vegetation gain, this type of color, and it is the about this type of color identify about that low vegetation gain, low vegetation loss, and high vegetation loss as the red color. Okay, just we are doing for that linear regression trend analysis, and I show you the later about that for the further class. In this time, Mann-Kendall also you can do for the this type of analysis. Suppose we can get the high trend of the precipitation, low trend of the precipitation. Okay, with this type of things we can easily do. Okay, so
And
basically, yeah,
like Mr. Rahman, here how can we correlate like with the Mann-Kendall precipitation walo say ये NDVI को how can we compare like this point is for example if you open this Mann-Kendall precipitation.
yes, yeah,
Yeah, if you see this this blue ones are there, no
yeah,
blue
is the
pixels.
high trend, yeah,
How a high trend, how can we show the area is for example how is the vegetation in these areas in the blue areas,
yes,
can we compare them yani to to put it in a bar graph like you
So
have
I also show you
this.
that in this time you can see. So it's our next topic about
Yeah,
that we talk about for this time. So so these things it will be covered for
yeah,
this.
the
Okay.
same thing.
NDV
Yeah,
and
the same
rainfall or
graph,
precipitation.
the
Yeah.
same graph. Here, Mr. Rahman, one second. Open. Yeah, this one it has different boundaries, Mr. Rahman. Like for example, this boundary is of the first boundary is of Dubai area.
Yeah.
Okay, and this entire blue area, blue and the light blue and all are that is another emirate. This is one emirate, this is another emirate. Can I segregate as per the emirate basis, Mr. Rahman? Can we do that?
So I don't understand about the question.
Yeah. Now this entire
Yeah,
shapefile, it has different emirates, different kingdoms, yani. Okay.
yeah,
For example, Dubai shape, Dubai area, Sharjah area, Fujairah area, like that. You have different emirates,
yeah.
Mr. Rahman. So I wanted to know, emirate wise, like for example, in Dubai Emirate, how is the comparison of NDVI with the rainfall? In Fujairah area, how is the comparison of the rainfall and the precipitation and the NDVI, like that?
Okay, so it also possible. So basically, okay, it also
Ah,
possible. So for that, we have to
ah,
also create the NDVI map for this region.
yeah, yeah,
Okay, we have to create the
yes,
NDVI
yes,
map for this region, and then so mainly
yeah,
where we can find out the more rainfall or more precipitation, then we find out here the
yeah,
better or well vegetation. Okay, so it's
yep,
also
yep, yep,
possible for that.
yeah,
In this time you can also do it for here.
yeah,
Suppose you can simply make a ndvi map, and then you can easily
yeah,
check the
we'll make,
result about that. We can get the better vegetation in this region than this the red color
yeah,
vegetation. Okay, so you can also do it. There is no
yeah,
problem. We also showing about that.
mm,
So for that, okay, so I'll show you that later. So I complete all of those things properly. So I also write about that your comments. So it's that showing about the precipitation and ndvi, okay, in map. So basically, where the precipitation is the high, we find out the good vegetation. This type of things we can easily do in
vegetation.
Google Earth Engine platform, and also compare the result with the precipitation and ndvi. Okay, okay, so let's I also show you the process, no problem. Okay, so let's go on next slide. So now we talk about the global satellite mapping of precipitation. Okay, so it is a you can easily access this type of data from that Google Earth Engine platform, and we can find out the hourly what is the condition about the precipitation every hourly or 3 hours after interval. What is the condition about that? Okay, so let's go. Just I simply take a new code editor. Just just I simply open the code. So in this time I use your own region. Just I simply remove that previous one. Import that. And you can see which file I want to use in here. So I use the shapefile variable name. Okay, zone 1. Okay, just simply copy the zone 1, this shapefile variable name. And now I also focus the center of the shapefile. We have the map.center object. It's a zone 1. And then click OK. Okay. Okay, so it's not take the Mars precipitation. Okay. So okay, so we just simply put here the suppose year of 2023. 9 1 9 11 year of 2023. So this time period, what is the condition about that precipitation? Okay, in this time we have to stress about that for getting the bit. So just like simply in the stress 98%. Not mass. This variation here. You can get the 0 0 and apply. Okay, so recently, do you remember any date for the when the rainfall occurred in this region?
Yeah, in say 2022 July 28th.
2022 July.
July 28th. July. Yeah, the entire. Yeah, you can see the entire
July
month. Yeah, July
and date
7, 28th, 26th to 28th. So to make it 28.
28.
Yeah.
Okay, 22 and suppose put it at the suppose 30.
Or okay, make it 26 to 30, Mr. Man. 26 July to 30 July. Yeah.
Okay, so you can get the time series exactly.
Okay. Okay.
July 28. Okay, July 28. It will be happen for that 0.39 millimeter per hour precipitation for this region. 0.39 millimeter per hour.
Uh, can you make it say 26th, from 26th onwards? Shall we check?
Put it at the 26.
Yeah, 26th to 30th. Yeah. Now go. Now see.
Yeah, so now we can get the some piece variation. We can see. So we can get some distribution about that. So now it will be work. So just simply increasing 98%. And you can get the value you can see. Lowest is the 1.9, highest is the 1.6 millimeter per hour. So apply it.
Oh, okay.
So now we can get the some distribution about that pixel value.
See, yes.
Red in this time red is identify the highest value. Yeah, highest pixel value.
Highest rainfall, huh?
Yeah, highest rainfall. Then this time check the pixel value from here. You
Ah,
can see. Just click on here.
okay.
Hourly precipitation. I can get the 1.6 millimeter per hour for this region. We can also get the coordinate also in here. Okay, for this region, 1.6. Also you can see it almost 1.7 or more, you can get the result. So in this time we can get the result. So basically for the very short time when you want to do for the analysis hourly we can easily get the result, and it also provide you the time series chart about that you can get. You can see, yeah. So now it also better, you can see we can get the time series chart. So you can see the 26 1.6 millimeter per hour, and in this time you can see the 26 I can get the lot of time data. So basically this data set provided
Yeah.
you the data set hourly, every 3 hours, every one day, every 3 hours time interval we can get the data. So that's how we can get the data
So
look like that.
So most of the rainfall it happened on 28th. Okay.
Yeah,
Before 27.
27 showing the 27
27.
6.7 millimeter per hour.
Okay. Before 27 only. In 27. Oh, okay.
So in this time, okay, so you can either download the CSV file format and show the result from here. You can get the result. hourly precipitation rate. What is the every hour you can get in here. Okay. So now I can see here how I can create this type of work. So first of all, we have to import our boundary shape file and give the variable name is the zone 1. So in this time, we are use this satellite images. Just I simply copy and paste this in here. Then we can get all of this information about this data set. So we are using here this data set, global satellite mapping of precipitation. So this data set provide you the hourly precipitation data for whole world. We can get the data from year of 2014 to 2023, this time period. And this resolution is that
This is from
you can see
NASA.
yeah, NASA. It provides the NASA data satellite events we can easily get from here, and its resolution is not so good, but it also very well for that short time analysis of precipitation. Suppose for today, what is the condition, or past tomorrow, what is the
Okay,
condition of the rainfall or precipitation? So it's very work well for the other data set because it provides the hourly data set, hourly precipitation data set we can get from here.
and- understood. Mr. Rahman, depending on this data set, can we? Is there any possibility to predict, say, in the next 6 months with the help of this present data? Do we have anything in Google
Okay,
Earth
it's
Engine?
also possible to use the we are use here that Python for the prediction and also
Ah,
identify about that.
achha,
Suppose I can get the time
ah,
series data. Now using this time series data, what
yeah.
is we can easily predict what is the condition about the for
Okay,
next
okay.
5 months, but not showing the
I,
display. What is the suppose this type of raster is not possible for
ah,
doing in Google Earth Engine platform.
no
But Google
problem.
Earth
Yeah,
Engine
okay.
platform, we can easily get this type
Ah,
of precipitation data. This type of data we are use the Python, and then numerical analysis we can easily do and predict for the any further what is the rainfall. This type of work is also possible to do that. Yeah, possible to that.
can you show a small example,
Okay, I'll just show
Mr.
you the
Rahman?
a
Maybe.
small example about that. How we can easily use the predict. Mainly, suppose using the
Yeah,
ndvi and LST. Suppose one example is that ndvi and LST. What is the suppose when is the LST is the high? What is the condition of the ndvi? This type of analysis we can easily predict.
okay.
Suppose we can put any types of LST value and then check what is the condition
Ah,
about the ndvi for this LST value. Okay, so this type of work I also show you that for the later. Okay, so for how we can
ah.
easily use the linear regression. Okay, about that for that mainly we are using the linear regression to predict anything, any numerical value.
Yeah, predict.
Yeah.
Yeah, yeah.
Okay, so I'll just show you that.
Maybe one second, Shreman. Maybe for this uh, precipitation data, we will do once, Mr. Rahman, to predict the precipitation, rainfall
Yeah,
in the future
yeah.
with this data. Okay, I mean, upon your convenience.
Okay, okay, I show you that. Okay, I will show you that. No problem. For the one example. Okay. So in this time, we can simply import our image collection in here and then choose our time period
Yeah,
when the precipitation will be occurred. Just simply put this time period. And then in this time, we have to
yeah,
use
yeah,
here the band. In this time, this band is the hourly precipitate rate, hourly
yeah,
precipitation rate. Just use this data set
yeah.
and then we are display the
Mr.
image.
Rahman,
Yeah,
Mr. Rahman,
yeah, please.
Mr. Rahman, do you have that Python code for that prediction?
Yeah, yeah, I have also do that. Yeah, yeah.
Oh, okay, okay.
Okay, so I'll show you that and also put the practical example. Then you can easily understand about.
Yeah,
Then we are simply study it and then get the better result for the visualization about that precipitation on the day
okay.
and show the okay. And how we can easily make this type of time series chart for creating the time series chart. Just we are using here the same function UI chart image dot series. This function we are use, and then first of all the collection. Okay, so collection in this time this is my collection precipitation hourly data set. I want to check how many images I want to use in here. Just use here the same function. Use the print function and copy and use f size function. So now it's calculate how many images I use in here. 96. Okay, for this time period, I got total 96 images. Okay, and this map is created from the 96 images average result. And this chart is showing about the total
Oh,
96 images. Create this chart.
oh,
So just we are showing this precipitation is my image collection. Basically, this variable is stored at the 96 images. Then this my shapefile
mm-hmm.
variable name. I use at the reducer. Then we calculate the result about that. And then this type of support you can in this type we can see the chart is look like this type of point. We are also using the this type of color and background color
What,
as the ash
yeah,
color.
what
So
is the scale, Mr. Eman? You said the scale is 1,000. What does that mean?
okay, so basically it is the resolution about the satellite images. So in this time, okay, so I think in this time we are also reduce the scale about that. But in this time, yeah, so this is the actual scale about that. So 111,132 meters is the actual scale about that. Excel means the pixel area. So in this time, one cell. Suppose in this time, red color. Suppose in this time, you want to calculate, simply export it and calculate that ArcMap software for the cell size. Suppose this cell, it is a one cell. Suppose it's a one cell. Okay. So this one cell is cover, the area is that 11,132 square meter.
Meters.
Right? It's a square meters. Yeah.
Oh,
So it's covered this type of area. So after that, we are just using the save button function and put the title about that. Okay, and also you can see the we are using the italic font. Okay, then bold color. Okay, we have put here the color code. All of this will be same. Just you are just customize our time series chart and get this chart look like that better view for the for this type of look like better view you can get. So now you can download the chart as a PNG file format. Also download the chart data as a Excel file and represent it. Okay, so this is the process about the global precipitation satellite data, how can easily use. And then also in this time you want to use the data set and make the trend analysis, same approach for the Mann-Kendall's correlation. We are also apply using this data set and show the result. Okay, for the different. Also basically it also work for the short time very well. If you want, you can also put here the long term. There is no problem. So basically this data set is available for year of 2014 to 2023. You can get the data set between this time period. So let's go to the next slide. Okay. So basically these data set is work very well, and it's also this data set accuracy is also well, because in this time this data set is the combination with the station wise data. It also make the data set with the combination of station data. So that's why this data set we can get the very good accuracy. The CHIRPS painted data. Basically, CHIRPS painted data we can get the two types of data. One is the daily CHIRPS data. Another thing is the painted. So every 5 days data we can get from here from the CHIRPS. Okay. So now I show you that how we can easily work with the data set for the CHIRPS data set and work for the different types of analysis. So let's go. And also make the 1 year time series chart. Suppose you want to make this type of 1 year time series chart. What is the condition about the precipitation? Then also you can see the annual precipitation, how you can easily create about that. So let's just simply copy this code link from here. Just simply change that area of interest. So now click the run. And check. Okay, so this is the result about that. In this time, here we can get the two types of map. One map is generating from the 1986 to 2015. Suppose this time period, all of those data set I create, okay, and then make this map. And another is the one for only for the single map. So in this time it look like that. So I simply use the symbology. So just visualization parameter and click the 98%. So now I can get what is the for this region, what is the mean and max about the value. So just I simply apply that. Now we can get the some distribution about that precipitation or rainfall.
Mr. Rahman, can you change the date till 2022, if you don't mind?
Okay, 2022.
Eight, yeah, 2022. 2022. I think till August.
August.
Ah, 808. Yeah.
Okay, so run the code again.
Right. Here, the dark green is what, Mr. Rahman?
Yes.
Dark green is what, positive value, high, more rainfall.
Yeah, just I show the visualization. Click on here. Okay. In this time, you can see here. In this time, we can easily change the color. Suppose in this time, this color identify about the low. It's that
Okay.
greater than, and it's the highest. So I simply put at the suppose blue color as a
Okay.
rainfall. So then simply custom 98%. This time we can get this value and then apply. And I also just simply copy this value from here. This value copy and paste here. And also check the first layer. In this time it's showing the result for 2022. So the result for as a it is a color and custom 98%. Okay, so now simply copy that. So now click the run again. It's loaded. Okay, so it's not changed. Okay, okay. We have also just simply copy this color code or hexa code
Yeah, it changed now.
and then also change in the color in here. So
Yeah, now I think it changed.
paste and also paste. So now we can, when I run the code again, I can get the blue color also.